Hello guys, welcome back to Constorm. So today we want to look at QGIS for beginners. If you are an absolute beginner, you have no idea how to use QGIS, this video is for you. So on my screen you can see the QGIS interface. This is how it looks. But before we dive into what we're going to do, we first need to download this software. So on your browser, just go to search for QGIS and you'll see something like this. So just click on download. There are different ways on how you can install QGIS. So first, when you land in this page, just click on download. And when this opens, you'll see a few options on how you can download QGIS. So let me just skip these because I don't want to donate. But this is how we can download QGIS to your machine if you're using Windows or Mac. So I'm using Windows. So on my screen, you can see I have different options on how I can install these. I can use this online installer. It is actually the recommended version. You can download these, but I'd prefer we go with this one. So just click on this. It's around 1 GB. So once it starts downloading, then you can proceed and install this. It's just straightforward. So since I already have it installed, I will not install it. So I'll just skip to the interface. But just finish the installation process and then you will land yourself in this window once you open QGIS. So this is the window we are going to be interested in looking at. And in our video, we look at a couple of things for you to get started with QGIS. So we have done with QGIS download. We look at the QGIS interface. We look at the GIS data types that QGIS supports. We look at plugins, data loading, projections, vector data types, attribute tables, raster data types, basic spatial analysis. We look at databases and then we generate a map using QGIS. So let's dive to the QGIS interface. So this is the QGIS interface. What you look at, what you are looking at is the QGIS interface. At the top, we have the menu bar. You can see we have the project. You can create a new project, open, save as, save, and then all these options. You can see we have other options like edit. We'll look at most of these things. You have the view option. There are some of the things that you can use in this panel. We have the layers. We can create layers using this option. We can add layers using this option and many other options. We can remove layers from this option, but then there are still shortcuts on how you can do this. We have the settings, which we will not look much into because it's not necessary for this. We have plugins, which is very important in QGIS. We have vector. How do you process vector data types? We have the raster, same data type, how you process raster data sets. We have database and how you can connect to databases. We have web, how you can access online web maps, basemaps, and many other options. Again, the processing option is very important. This is actually the core of this software, and this toolbox, we'll look at it. So that is the menu bar. On the left, I have the layers control panel and the browser. So I can browse layers from this option. So this is the browser option, and this is the layer. Again, I can dock this wherever I like. I can make it the first. I can dock it to fit on top of the layers. So it's just a matter of playing. It doesn't matter how you position them, but I do prefer mine being like this and layers being the first. I have the locator bar down here. I have the option for coordinates and other scale, magnifier if I want to increase. And also have the projection, the default projection system for the software. So this is all about the interface of QGIS. So the next thing we'll look at is GIS data types. We have two main data types of GIS. We have the vector data type and the raster data type. So what is the vector? Vector is anything that has geometry. We can think of points, polygons, polylines, or lines if you like. Those are majorly classified as vector data types. Raster data types are anything that has pixels, like images. So we have different formats of images. We have the PNG, we do have the TIFF, GeoTIFF, especially it's very important because it has coordinates attached to it. But then there are options on how you can visualize a normal PNG on this software using options called georeferencing. So those are the two major data types. We also do have other data types like the WFS, that's the World Feature Service, and the WMS, World Map Service, also the World Coverage Service. So these are other data types that you can explore, but in this video we'll focus on the vector and the raster. So the next thing we are going to look at is plugins. Plugins are very important in QGIS. And you remember these are option at the top for plugins. Under the manage and install plugins, this is where we will be installing our plugins. So from here you can see you have a list of plugins that you can install to help you in your analysis or in your data manipulation. But in this video we are going to look at the core plugins that you need as a starter. And the first one is Quick Map Services. So you just search Quick Map, and once you click on it, so this is the plugin that we need, and you just click on install. For me, I've installed it, so that's why it's saying upgrade plugin, but you can just click install now, and once it's installed, you will be able to find it under web. So under web, you'll see these Quick Map Services, and this is what we need. So first thing we need to do is add a base map. It's very important to add a base map. So in this option, we are going to look at different base maps that this plugin offers. This allows you to know that your data is falling on the right place on the map. So you can see this icon. It's called Search QMS. So it's Search Quick Map Services, and you can search any base map you like. So here you can see I've made a few searches, and I have Google Satellite. I can click add, and once I click on add, it's going to be added on my layer panel. So you can see if I toggle this on and off, I'll be able to see, and I can add as many base maps as I want. I can add Google Maps as well, and if I turn this Google Satellite, you can see I have Google Maps. So this is how you play around with base maps. The next thing we'll look at is data loading. So this is now, we're getting to the core of this software. We need to have data to visualize. So for you to add data, you just go to layers, add layer. So for the first instance, you're going to load a point data. And again, we said points are vector data sets. So you can see we have different options to load different data types. And for this first instance, you're going to add a vector layer. So click on vector layer. You will see this window. Just click on these three dots and navigate to where your data is. So this is the folder that has my data. And I can add any data that has a .shp extension or GeoJSON. So again, we need to look at different data extensions that are accepted in this software. So if you click on all files, you will see the different data types that are accepted. If you have any data that fits this extension, then that data will be loaded to your interface. So in this scenario, I do have some GeoJSON, so I'll click on these and open them. Once I open them, I'll click add, and then I'm going to close this window. So it's just loading because I think the data is big. So initially you're not going to see all these data points because we have the basemaps loaded, and this is because these basemaps are zoomed in to the whole world, but these points are to a specific place. So how do we manipulate this data to be visible, to be zoomed in, or rather? So first thing you do is click on that layer and right click. You will see different options pop up. So just click zoom to layer. This means it's going to pan in or zoom in to where your data is located. So these are a lot of points. That's why it's a little bit lagging. But the whole essence is having these points to be displayed to our area of interest. So actually these points are for Kenya. So let me pan in a little bit. I don't know why it's taking so long. So let me just turn off these base maps and zoom in again. So once you zoom in, this is how it appears. So if we turn on one of the base maps, this is how you see. So these are the points across the Kenya, and you can see I have a lot of points. So some of the best practices you need to do is save the project. So in case the software hangs or crashes, or maybe you're using a desktop, the power goes off. So just go to project and you save as, or you can just hit Control S or use this icon up here. So I'm going to save these maybe under here, and I'm going to say anything. Just let me name it project and save these. So this way I'll know that anytime anything happens, that I'll have my initial state stored. So we have loaded our data. This was one way on how to load the data using this option. Another option is to use the browser. You can browse your data, so you can see, you can access your folders using this option. So I'm just going to add another data for some polygons. Again, this you're dealing with vector. I'm just going to go to this folder, and maybe I can add this folder. So the good thing about this, it automatically shows you all the data types that has the right extension. So in this case, I'm using a SHP, which is shapefile. So just double click on this or drag and drop. And you can see now I have two. So what I do, I can just drag this below the points so that I can have the points overlaying the polygons for easier visualization. So now I have the points across Kenya and the counties. So these are the counties, states in Kenya. So yeah, we have handled the first instance, loading the data to our interface. This is a big step in your learning. So what do we do next? Maybe you want to analyze what sort of data does these points represent. So the first thing you need to do is select the layer and right click on it again. You can see a lot of options when you right click. We are interested in the attribute table. So what is an attribute table? An attribute table is sort of an Excel to this data. It shows you the number of records you have for this related data. It has columns, as you can see, that represent each feature in that layer. A layer is a collection of data. So in this case, we have points and we have this attribute table. You can see the feature count. It has 53,650 points. And you can see the states. We have not selected any. We'll make some selection so that we can use that selection later on. So how do we make selection from an attribute table? So when you want to make a selection, you can see we have these icons up here. I can edit a selection. I can select these and remove it and delete this option. I can delete this using this icon. I have to select this icon first. It's called editing mode. I have to edit. I cannot, if this is off, let me not save that, whatever I've deleted. If this is off, it's not highlighted when you want to do any editing. We will not be able to delete anything. I hope we're clear. I will not be able to delete anything. I will just be able to select, but I will not be able to delete because this is off. But if I turn this on, I'll be able to do a lot more with these icons up here. So that's part of what we call editing. So these are some of the basic editing strategies you can use. So I don't want to delete anything, but you can see I have other options. I can add a feature. Just click on this and I will have a new column. I can input maybe an ID. I can add a code. What is it? Is it a school? Is it a hotel? But this is not the right way to add a feature. So I'll not be doing that here. We'll do it on the map canvas. You have other options. You can cut selected rows, copy, all these options. But let's turn the editing off and discard any edits you have done. So what I want us to do is select schools. You can see I have other features. We have camps, schools. We have a lot of options under this column F class. This is what we are interested in because this has unique values that we are interested in. So how do we do this? We use the expression option. We select by an expression. So what you do, you click on this icon and you see this pop-up window appear. What we are interested in this is this field called F class. So under this window, you will select fields and values and double click on the F class because this is the column we want. If you want to use a different column, you will select that column here, select the equal sign and go to all unique features. In our case, we are only interested in schools. So I'm just going to find schools. It's down here and again, double click on it. So you see, initially we had a red error here saying that this expression was invalid. But once we added a unique value after the equal sign, this disappeared. So you want to select all the points that are marked as school. So click on select features. Once you have clicked here, you can see all the schools have been selected. And if we go back to the map canvas, you will see that all schools have been highlighted in yellow. Good progress. Now, how do we extract these schools to be a separate layer from the whole point layer? So what we do is right click on this and export selected features as. We only save the selected features. If you wanted to save again the whole layer, use the first option. But now we only want to select only the ones that we have selected. So click on that. So we get this pop-up window and we need to save it to a location. You can select a different format. There are a lot of formats, shapefile, GeoJSON. Let's stick with GeoJSON. And I want to save these to here. I can name them schools. Let me call it school and save this. Click OK. I've checked this option so that once it's done saving, it will load them back to the map. You can track using this. There's a bar here. So let's turn off the POI layer and we have only the schools. Good progress. We have successfully extracted the schools from the layer that had several points. But do we need these points, all of them, to be analyzed, or do we need them for a specific county? Again, we need to do for a specific county. We are not interested in analyzing or visualizing maybe for the whole country. Before we go to how do we extract points for a specific county, we need to explore a few more features. Let's close this window for now. And we are here. What I want us to do, we want to see the attribute table for this school, for instance. How do I identify this? We use the identify tool. You see this icon with an eye. If you hover your mouse over it, you'll be able to see the label of function for that icon. So click on it, make sure that it's highlighted, and click on any school you want to to read the attributes. Again, you have to ensure that it's selected here, because if I select a different layer, I will not be able to get the information for that layer. So let's select something like this and click on this. I'm able to get the information about that county, what the name is, and all the other associated attributes. This is the role of the identify feature. Good. Other features we can look at is this, the pan. You can move the map around. You have the zoom in. I can increase the map by drawing a rectangle. I can reduce the map and take it the default, maybe another level. I can do I can zoom to layer by selecting this, and I can click on here, zoom to layer. If I zoom in and I click on this again, it's going to take me to a default view. So that's what we call zoom to layer. So these are some of the basics that you can interact with, and you can see how they work. You can play around with them. So let's talk about selecting. We want to do a specific county. Let's select a random county. So click on the pan just to avoid any misbehavior when I click, and I'm going to close this window. So let's select a default random county. Let me zoom in. You can play with your fingers again, still works. Let me select maybe the capital city of Kenya. I'm not sure where it's around this place. So how do we, let's do a specific county for Kenya. So this is the layer that has the counties. So I'm going to select this and open the attribute table again. We'll do the same thing we did with the point. So I'm going to go to the expression again, and I'm going to go to fields and values, just like we did. Now I need to be sure what column has the names of the counties. From the look of things, is this column name _1. So that's what I'm going to double click on, put the equal sign, and get all unique values. I'm interested in Nairobi, so I'm just going to look for Nairobi and double click it. Save, select that feature, and if I close these and go back here, you can see Nairobi has been selected. So this is the county. Using the same technique, right click and save the selected feature alone. So again, maintain the JSON, and I'm going to save this as the city. I'm going to save this, and I'm going to click OK. Now we have loaded our area of interest. This is what we call our area of interest. We only want to visualize the schools within Nairobi. Again, you are seeing now the essence of the base map. If I turn this data off, you can see this is Nairobi. This is the role of a base map. It helps you guide you and actually know that you're working on the right place. So let's turn the city on and the schools on. Good progress. Now we need to extract the schools only within Nairobi. We don't want these other schools that fall outside the boundary of this city. We don't need them. We only need to extract what we have within this boundary of Nairobi. So this is what we call vector data analysis. Now we are at vector data types. This is vector data analysis. So what we do, on the main bar, we go to vector. You see we have different options. We have the geoprocessing tools, we have the geometry tools, we have the analysis tools, research tools, and data management tools. We need to look at geoprocessing tools, and we need to do what we call a clip. It's like when you crop a picture. Now in this, we call it a clip. The input layer is the layer that you want to clip, the layer that is extending outside the boundary, and in our essence is the school. The overlay layer is that boundary where you want to limit your schools within, and that's the city. And I'm going to, you can save it, but in this case, let me leave it at temporary, and I'm going to run this. So it's done. I can close this window and I can turn off the school. And you can see now we have only the schools within Nairobi. Let me rename this. You can right click and rename this to Nairobi schools maybe. So we have our Nairobi schools loaded here. Again, good practice is to save the project. And these are the schools within Nairobi. You have successfully performed the clip operation on a vector data type. Good progress. So let's look on how we can perform some simple styling. We want to style these Nairobi schools to be a different color, different size, or maybe a different icon. One option is double clicking this layer to open the layer properties and going to symbology. That's the first option. The second option is right clicking and going to properties. Still, it lands you the same way. But my favorite is selecting this layer and clicking on this brush icon just here. This opens this window. And you can see you can be able to style whichever way you want. So I can click on this color icon and I can change this to maybe, let me say red. And this allows you to view the changes as they happen. So let me do something like this. Let me stick with red like that. You can see I can visualize how the layer color or symbology is happening in real time, unlike the other options where I have to close and then keep on redoing that over and over. Once I've selected the color, I can go back and increase the size. I can maybe do the higher the size value, the higher the icons. This does not look good when the sizes, the schools seem to be overlapping each other. So I'm just going to reduce this. So let me say that level. I can do further styling. I can select this. I can select this. So let's stick maybe with this green icon. I want to reduce the size and do something like that. Great. So this is the basic visualization for this point. This is how you visualize or style a layer. Let's do something about this boundary. I'm going to select it again and automatically this window will change. So let's say we do not want the yellow fill. How do we do that? We click on this simple fill here and fill style. So you have different options, and if you click on no brush, the color disappears. If you click on solid, the whole color will appear again. So no brush is good. You can try the other options. You can change the stroke color, the boundary color that is, to any color you want. And then of course, you can change the solid line. Maybe you want dashes or anything. And again, I can increase the size of the outline. So this is how we style these layers in QGIS. Now we have something to work with. We have clipped. We have our schools only within Nairobi. This is good progress. So what if I had missed a school? How do I do that? Maybe there's a school close to this airport. Let's say around this place. We know there's a school here, but it was not added. How do we add that school? So for us to add the school, first select the school layer, Nairobi schools. Click on this pen. So this means you want to start editing. We talked about editing the attribute table, but that does not place that point where we want it to be. Let's add it through the map and see if we will be able to see it in the attribute table. So once you click on this pen, some of these features will be enabled and you will see this pen for the layer name. Remember, these are points. So we need this icon. So add point feature, because the layer itself contains points. A layer cannot have points and polygons. It can, of course it can, but by default this layer came as points. So once we click on this, I will be able to see this icon and I can click on it. You see what we did? Let me cancel again and click again. So the same fields that were in the attribute table will pop up and you'll be able to fill it. So I can say this is a random ID. I can do another code and I can say this is a school. And I can name it my school. So if I do this and I click OK, that point is going to appear there with the same symbology that we used. If we open the attribute table of these and find, that's the first thing we did. This is the new point that we have added. Close that. And now to save this, click on the pen again and save that. We have successfully added a new school to our layer. Now that is called data editing. We have successfully edited this layer, added a new point to our existing points. Until there, you have the basics on how to improve your data by adding or removing data. Okay. Now let's do some general selection. I want to select this point, but I don't want to search it through the attribute. I want to select it from here, then delete it from the attribute. Let's do the point that we just added, which was this one. You see, by default, it's selected. I can deselect all points. So I just go to Edit. You can see I have the option to select, and I can deselect features from all layers. And you can see it has been deselected. It was yellow by default because we had selected it. Now I want to remove these. I'll go back to Edit, select. I can select by just by a polygon, freehand, radius, anything I want, but let's keep it simple and just select feature and just draw a small rectangle. You can see it's been highlighted to yellow. If I open the attribute table again, this has been selected, so I can just show selected features from this option and I'll see it here. Now I want us to delete this point. Click on the pen again. Now you can do it from the attribute table and just delete. Click on the pen again and save your edits. Close the attribute table and that school is gone. That's about selecting and deselecting features. So for you to keep working with peace and with ease, click on the pan, because by default we still have the select option. Click on the pan so that you can be able to again maneuver the map with ease. You can right click and zoom to layer for easier rescaling. That is all about vector data processing. Another thing to do is, let's talk about data projections. We skipped that, but let's go back to it. We have two types of data projections. We have geographic and projected coordinate systems. So these define how points are placed on the map. So by default, we have the 4326 on your bottom right. You can see the current CRS, coordinate reference system, as 4326. This is a geographic. So anything in geographic is measured in degrees. And we need to, for you to do an accurate analysis, you need to convert geographic to projected. So first thing you need to know, you need to understand where your data is located on the map. Which zone does that fall under? A great tool to use will be anglemap.com. It allows you to know where your data falls. So ours falls in Kenya. So I'm just going to find Africa. And Kenya is here. So Nairobi is most likely is here. So this is where my data mostly falls in. So here is my Nairobi, and you can see the zone is 37 south. So this is the projected coordinate system of my data. So you can find yours using this site. It's called mangomap.com. So this is what we need to convert our data to. So but currently the data is in geographic. And how do I know it's in geographic? Let me close this. We don't need this now. How do I know the data is in geographic coordinate system? You can right click on this and open the properties. Once you open these properties, it will be able to tell you what projection system it is in, and I can go to source and you can see the coordinate system is described here, and this anything that has WGS 84 is geographic, and if you hover over it, you can see geo means geographic CRS. So this is what we are working with. We need to change this to a projected coordinate system. How do we do that? Select that layer, go to vector. We are still working on vector. Go to data management tools and reproject layer. So this means we are changing it from geographic to projected. So the input layer is the schools and the target CRS. So this is what we want to project it to. We want to change it from geographic to projected. Click on this map icon and search for your UTM zone. So mine, I've said, is UTM 37 south, and you can see it pops all the options that are for the UTM. So anything that has UTM is projected by default. Doesn't matter if it's WGS 84 UTM, but let me stick with the first one. And I'm going again, if I maximize this option, let me see if I can. You will be able to see if it actually falls, and you can see that it actually falls in Kenya. This is what you're interested in, and just click run. So it's going to save a new layer. Let's turn off the old points, and this is the reprojected schools. Let's rename this and call it reprojected schools. So this is our projected school data. So if I click on this, open the properties again, go to source, I'll be able to see, if I hover, I'll see proj CRS, meaning you have successfully projected this from geographic to projected. You cannot change it from here. If I change it from here, it does not affect. So if I were to go back to the Nairobi schools, the original layer that was in geographic, and try to change these, let's open the attribute, the properties. It says use the reproject layer tool, because if you change it from here, you have not reprojected. So don't use this option. These are no. Good. Now we have reprojected our schools. Now we can do further analysis using these tools. Now let's create a buffer around these schools. Let me say I want to know how these schools overlap, and maybe my client wants to know how many schools fall within a buffer of 500 meters. So I'll select this, go to vector, geoprocessing, and buffer. So buffer is where you create sort of rings around these points or polygons or whatever lines at distance. So we do a radius. You enter a value in radius and in any units you want, and then it will draw a circle or a polygon that you call a buffer. So why do we need the projected coordinate system? Because that way we can be able to use the actual units that make sense. The other one uses degrees, and degrees are a little bit complex. You need to find the right translation, what 1 degree represents in meters, and so on. So now we need in meters, and the distance we need, this distance is the radius. We need a buffer of 500, so I'm just going to input 500 meters, and anything else you can leave it as default, and I'm going to run this. So this is what it does. It creates buffers around each school. So these pink circles are the buffers. So let's rearrange these and put it below the schools, and you can see how these rings fall. So you can, using this information, you can make a decision which areas actually have a lot of schools clumped together and which areas need more schools. Because maybe if these schools need to serve children within the radius of 500, you can see some of these areas like this one has a lot of residential but very few schools. Within the center of the city, there are a lot of schools, which means they are over-serving the kids that live around that place, maybe something of that sort. So this is another analysis you can perform on vector data. Let's do one more for us to maybe understand more about this. So let's turn off these the points and remove the buffers. What if we need these buffers to not overlay like this? You see, like this place, a lot of circles, it doesn't look clean. What if we merge all those that overlap to form one polygon? For that, we have to do what we call the dissolve or merge. We merge those that overlap, like this one. So these are two different schools, but they serve literally the same zone. We don't want these circles looking like this. So what we do, we go back to vector, geoprocessing tools, and we dissolve. Geoprocessing tools, and we dissolve. So click on dissolve, we project the buffer, that's what we are interested in, and we run this. Once we close this, if we turn off the original one, you can see now we have those buffers that overlap each other will be merged, or rather their boundaries where they overlap will be dissolved, will be removed. Now areas like this, initially let's turn this on. Let me move this down and open the buffers. Initially you could see how the buffers were just overlapping each other. Now once we dissolve that, we're able to see that these zones, they have a lot of schools which overlap each other. They overservice each other, or maybe the population that needs to go to school. So that is it about basics about vector data, how you can handle it. The next thing we need to do is we need to look at raster data types. What is a raster data type? We have talked about vector. We said vectors are points, polylines, and polygons. Now let's talk about raster. Raster is an image, is a pixel. It has pixels in it. It's like that image you take, that photo you take, that's a raster image. It has a PNG, a JPEG, a TIFF. That is a raster. In GIS, we can talk about satellite images. If you have heard of Landsat, Sentinel, DEMs, digital elevation models, that is, they represent the surface. So in this scenario, let's illustrate something with a DEM. A DEM is a digital elevation model. Shows how the surface is, the ruggedness of a surface. Is it hilly? Is it flat? And you can generate a lot information from that. So for that, we can add it through one of the ways that we talked about. I can go to layer, add raster layer, or I can go to the browser, go to that folder, which is this one, and look for that TIFF. So it has a .tiff extension. TIFF is a raster sort of image. It's an image. So I do have the image here. So let's go back and turn off some of these to keep this clean. So I have this image. This is a DEM, a digital elevation model. This is how you load it. a raster does not have an attribute table. If you right click on this, it does not have an attribute table. It means you cannot be able to read it. It doesn't come with that extra information about each point, each pixel. So that said, what can we do with these? So this is a section of a DEM in Nairobi, and what I want us to do is want to visualize this first. So again, using the same scenario, using our open window here, you can click on it, highlight it, and you can see this is the name we want to style. Let's do this in maybe different colors. You can use the single pseudo color, and you can see we have this where it says that any region, it's coming from blue to red or to brown. Blue are those areas that have the lowest values, and brown have the highest values. So in typical DEMs mean that lower values represent areas that are almost flat, and these higher values represent areas that are higher, above the sea level. So these are you style raster information, raster dataset to at least communicate to you, rather than having it to just have a continuous color. You can use different colors, and under this option, you see we have classified. We haven't classified it yet, but if we change the mode to maybe equal interval and assign 5 classes, you can do even 10, whichever number of classes you want, it will still show up. So you'll have these colors, and you can always change the color lamp as well. If you do not like that, you can click on this drop down arrow, and you can just select any color you want. This way you can be able to visualize and try to understand your raster data. So we talked about this processing toolbox. Let me close this for now. This is very vital. This is what it looks like. It has everything we have done can be found here. So this involves, this is not a beginner friendly way to learn this, but for more tools, you can find them within this toolbox. And one tool I want us to do is I want us to generate a slope for this area using this DEM. Want to know how this area flattens, where is it flat, which area has the lowest slope, it's literally flat based on this DEM, and which area has the highest slope, is steep, it's hilly. So to make it simpler, you just search slope, and it comes here, double click on it. It needs an elevation layer, which is by default a DEM. A DEM is an elevation layer. So DEM represents elevation, and slope, we generate slope from elevation. You just input the DEM and run it, no any other modification needed. So once it's done, you can see we have this slope, looks a little bit off. It does mention, let's visualize this. So again, I can click on this, and I can try to render this with a different color, showing me that most of these places are a little bit steep, and this area that is red, because red has the lowest value, let me expand this. Red has the lowest value, meaning these are the areas that are almost flat based on that pixel information there. So that's how you analyze slope. Sorry. So that is for raster data types. So before we wrap it up, let's talk about how can you connect to a database. So let me turn this off for now. So let's say you have data stored in a database. How can I access it without the need of downloading that data from the database to my local disk and then loading it here? To do that, there are a few options. You can come to layer. Let me minimize this. You can come to browser, and under browser you can see you have option that different databases. You have Spatialite, you have PostgreSQL, and these other different databases. Let's talk about Postgres. So for me to connect to my Postgres database, it's very simple. I have to right click on this and I need to create a new connection. That is if I've never added my database to QGIS. So I'm just going to give it a default name. Let me call it data. I can leave the service. For the host, you need to know the host of your database. So if you are hosting your database locally on your machine, usually it's localhost. But if you are hosting it on a cloud-based database, you need to have the host that you are given by the Cloud DB database and also the port. So this port again, for 5432, mostly you will find it both in Cloud DB databases and the local ones. So these might not vary a lot, but for my instance, this is the port I'm using. You need to put the database name. So currently, I think I do have a database. Let me try this. And then I'm going to test my connection. It will need a username and a password. So I'm just going to use my username, which by default, I did not change when I was installing Postgres, which is Postgres. And I will input my password and I'm going to click OK. So once I had clicked on test connection, and you can see the connection was successful. So that said, I can click OK to finish the connection. So if I were to come back here, I'll see that I have my connection here and I can open it from here. So how this works is it will fetch the tables or the schemas that you have in your database, and by default usually you have the public if you did not rename it, of course, and the topology, which I don't think I have any data in the topology schema. So I will open the public and you'll see I don't think I have any data there, so I'm just going to open this. But if by any instance I did have any data, this is what I will do. I just click on this and drag it on the map. So let's see if it was added. It was. Let's see, this one is not available. Let me try a different database, the ones that are existing. I'll try this one, and the username is the same, and the password again is the same. So if it accepts, so I'm not able to access this because I think this is a cloud database. Let me try this one. And the password. So this one I'm able to get information again, showing me the two schemas that I have. I have the public and this other one, topology. So topology, usually when you work with Postgres, you need to install the extension PostGIS that handles the topology of the data. And in this scenario, I think I have some point data. They might be too big because they consist of across Africa, if not across Africa. And I think that's why it's taking a while. I don't know if the database exists. But basically, this is how you connect to your database and configure it. Another option is to go to database up here on the menu bar and the DB manager. So once you open this DB manager again, you can use PostGIS extension or any other database that you want to connect. and I can import layer from the database by clicking here. And if this is not connected, again, I can just I need to right click this. Yeah, so again, once you had made the connection, you'll be able to see all the databases that you have, and you can be able to proceed and make the connection, because it will ask you for authentication, and you can configure that. So that's how you work with databases. And you can of course export data to your database by using the export to file. You can click on these. Let's do export. Let's click on maybe one of these databases. Once you have successfully connected to your database and you want to export to the database, you can of course export to file and or import. So maybe I need to import something, and I can do all these. So I don't need to have an existing table. I can create maybe for schools. And I can, if you had selected specific features, you can check these. Then the schema, you can keep it at public. The table, it can be any. So let's assume that is remains the same. And I can click. So the input here needs to be the projected schools, and the table will be these. Then I'll just click OK. So what this will do, it's going to import my data to my database, and you'll get a message that was successful. So that's how you handle databases in QGIS. So you can see the import was successful. So you can try these with other databases to see how that goes. So finally, let's create a map, because people associate these with maps. So let's create just a map for our schools. We did do some buffers, what we dissolved, and we can add some of the schools. So let's do something like this. We want to create this map for someone. Let's close this as well, and this. So how do we create a map and share this to someone as a PDF, as an image? So first we need to create a map layout by going to the project and going to layout manager. I can click on that. So if you do not have any layout, you can just use an empty one by clicking on create, and I'm just going to name these maybe something like map. So once I do that, I'll have this map canvas, and I'll be able now to start editing from here. So you have this blank, and a good map should have a title, should have a legend, should have a scale, should have a north arrow, should have some attributions maybe about the projection as well. So what we first do, we use these icons, and you can just hover on each to understand what it does. But first, we always start with a map, and you can see this icon of add map. So you'll get this option to draw. So I'll draw something from maybe, let me cancel this, and draw something from maybe here. Let's say I want my map to take this space, like that. So it's going to render my map, and you have it there. I can improve the map scale by coming to your far right, and maybe let's make this something like 100. I think that will make it bigger, too big. So let's do something like 200. Yeah, I think this is better. So we have added our map to our map canvas. So the next thing we need to do, we need to add a legend to this side. I can go to add items and select a legend. I will be able to draw. Let's maintain the drawing lines, and maybe I can do a legend to this size, leaving good margins around. So what this is going to do, it's going to add all the layers from the QGIS interface. Remember, we still have the QGIS open, so it's going to add all these layers. But again, our map does not have all those layers. It only has the schools, the dissolved buffers, and the Nairobi boundary. So those three are what we need to maintain. So just click on ensure that this legend is highlighted. It's going to appear here, so you can select it here, and we'll be able to remove what we do not need. If you scroll down, you will see we have all these here, and what we need to do is we need to remove what we do not need. So first thing is uncheck the auto update, and then once we have that, now we can start selecting what we do not need by removing one by one, or just selecting all at once and removing it. So as you remove, you can see they are also being removed from the legend as well. So it's a live view. We do not need the buffered, and of course we do not need these DEMs because we don't need to have them on the map. So we remove everything that is irrelevant, like that. So you have our legend. You have our legend here. So this is how you could basically style a legend. So this is just to keep you going. So maybe we need to have a black border. I can just come here to frames and insert a frame by clicking this, so that you can at least have it enclosed here. So the next thing we need to do is add a north arrow. So I'm just going to do a north arrow like this. Maybe move it a little bit to be centered, and also move these to be like that. So we have a north arrow. The next thing we need to do, we need to add a scale bar. Again, go to add items, and maybe you can do a scale around here. So we can move it a little bit up like that. Again, we can add some dynamic text like the map projections. We can do, let's do the WGS, so all layer credits, and we can be able to draw here. At least someone can know what projection the data is in. So this does not look well, so I'm just going to delete this, and I'm going to add a different one. Let's do this one. Again, this one does not look good, so I don't think we can do that. Let's add a label. Let's say the author of this map, and you can see we have the box, and let me do something like Constrom, and I can increase the size using this font option. If I click on here, I can be able to make these maybe, I don't know, 20 looks okay. So we can move these somewhere here like that. So finally we need to add a title. So I'm just going to add label again, and I can do something bigger, and I can say schools in Nairobi. And again, I can increase the size by clicking here on the appearance. So let's say the font, because this is a title, you can make it something like, let's say 50, even 50. Let's say 50, and then we can of course play with these and make it at least appear wholly. Let's move it to center it. Reduce this. So we have the title. So the final thing we need to do is maybe you can add a rectangle around it all. So I can add item again and add shape, add a rectangle. I just want to eclipse everything, draw a rectangle around everything. And you can see it's sort of overlaid everything because it has a white fill. So what I do, I'll click on the style using the same techniques we used before, and I'm going to click on this color, go to fill, and the style fill is no brush. So that way we have a rectangle around this. So we have our map ready to share. So what we can do, we can just increase this map. So let me turn off the rectangle, at least the map takes the space, and select the map so I can increase it to fit everywhere instead of leaving any blanks, something like that. So let's move it a little bit like this. Yes, and turn on the rectangle again. Yeah, so let's do another rectangle just for the left side of the map, and I'm going to do a rectangle from here to there, and I'm going to again make it no fill. So the style is no brush. It can be like that. So these, let's see the rectangle. Let's move the scale just slightly. Let's turn off all the rectangles and move. I want us to move these items a little bit below, so that we can have a good margin on top of the legend. Let's style them. Yeah, so let's turn on the rectangles, something like that. So again, we can add one more just for the title section. So let's do something like this, and again make it no fill, so no brush. So we have our everything is set. So we have everything ready for export. So how do we export these? We just go to these options. You have an option to export as PDF, as SVG, or as an image. So let's export it as an image and save it as a map JPEG. Save it, and of course click again save. Any warnings that may appear, just ignore them, and you can see we get a success message. So let's view how the map looks on JPEG. So if you open that, so you can see we have successfully exported our map as JPEG, and you can share these with anyone you want. So you can go, guys, try these. This is just the basics of QGIS. At least I've gotten you started on the basics. At least you will not get confused. Please support our channel by liking this video, sharing and subscribing it. And if you have any issues or get stuck, please leave a comment below, in the comment section below. Thank you guys for your time, and have a wonderful day.